Thank you so much for the very kind introduction.
Right.
I'm gonna set up my slide share. Okay, so it should be showing now. If you could confirm that the slide is showing. Hello? Hello, can you confirm if my slides are showing?
Yes,
Okay,
yes.
good. Okay, thank you very much. So I'm really excited to have a chance to speak to you today. I wanted to start off with a brief introduction, just to say a bit about my journey getting here and being able to speak to you. And so a little bit on my background. So I lived in Lagos. I went to school till I finished my, I guess, secondary school, high school here. I went to ISL. From there, I went to undergrad university at New Jersey Institute of Technology in New Jersey, where I studied electrical engineering for a few years. I decided to go to graduate school, and at the time I went to University of Texas at Austin, also studying electrical engineering. I finished in about 2013, and towards the end of my degree, I got interested in scientific applications of machine learning and artificial intelligence over my time there. And so I moved from there to Stanford, where I did a short postdoc looking at machine learning for neuroscience applications and topics like that. So this was a very interesting time. My office was actually like right around there. So it was actually a really good location. And I was there for about 2 years, and then moved on from there to University of Illinois, Urbana-Champaign, where I was a professor in computer science for about 5 to 6 years. Taught classes in machine learning, and I started some of the research that I'm going to talk about today. Towards the end of my time at University of Illinois, I decided to spend a year at Google, just learning a bit about the industry side of the machine learning work. And now I've moved to Stanford University as professor of computer science. And now I'm speaking to you from right around there in this building. This is the Gates building at Stanford. So it's been an interesting journey so far. My lab works, as you've heard already, on trustworthy machine learning and artificial intelligence. And the way that we define it is thinking about how one reasons through robustness of machine learning models, privacy and security of machine learning models, how these things trade off with applications that involve humans and how that affects fairness of machine learning models, and also how those end up affecting things like accuracy and performance. And importantly, we think a lot about the role of humans in helping to define, measure these notions of what we might call trustworthiness. And we sort of take very seriously the idea that much of machine learning directly involves people. And so we try to think about the role of humans in the loop in defining these measures, and then how do we implement ways to mitigate issues with trustworthiness when we find them. And some of this will show up in my talk today. I also want to mention that since about 2021, I've been president of Black in AI, which some of you might know, which is an organization that works on lots of things, but I think salient to this group, representation of Black people in artificial intelligence. So part of our work is thinking about how to make sure that Black voices are represented in who's building technology for artificial intelligence, how these methods are deployed, what the impacts are in the world. And so we do this through a variety of different mechanisms. I think one big one is an annual conference that we hold at NeurIPS every year. We also have graduate school academic programs, which helps in applying to graduate school with a variety of things, including helping with application materials, helping with fee waivers, few of these additional things to help with the application process. And then we have a variety of other programs, opportunities for networking, opportunities for community building, on all these other things. So if you're not aware of Black in AI, I'll recommend just Googling Black in AI. I think you can find our website and join very easily. If you are, just maybe friendly reminder for you. Okay, so now that I'm done with introductions, I want to move on to the technical presentation, and I'll spend 20 minutes or so, maybe 25 minutes, and then have time for questions at the end, hopefully. And I was asked to speak about applications of language models, both in research and in industry. And what I thought I would do, just because I guess I know that you've seen over the course of today lots of discussion about language models, but maybe a bit of history if you haven't seen this already today. So language models have a, I think, quite fascinating history. So a lot of the work in language models, as you might know, AI, machine learning language models have been around for a very long time. A lot of what changed recently, I think, can be attributed to the Transformer paper, at least in the way of thinking and the way of scaling these models. So there was a paper in 2017 that proposed a model, machine learning infrastructure called Transformers. And this, I think, really had a big impact on the community, showing that you could scale up language models in a meaningful way. I think this tied up also with a lot of investment from a lot of industry, some academia, had a big impact on the ability to build really, really large models that could do much more interesting things. So, some of this goes back to GPT, which is the early OpenAI model in 2018. Around the same time, Google produced BERT, which was at the time a larger model that was good at sort of word prediction, was used a lot for word completion. I'll say a bit about this in a minute. GPT-2 in 2019 from OpenAI advanced this a little bit more. Going on to explosion of models later in 2019 to where we are now, where I think OpenAI is leading a lot of the public face of the most interesting language models, very large models. And then many of the other tech companies, I think, are also following suit. And other players in the industry thinking about ways to build models or deploy models. So there's really been an explosion of interest in language models broadly. It's also worth saying that while the models can be quite sophisticated, and we'll talk about applications today, it's useful to know that under the hood, language models are trained for sort of fairly simple kinds of applications. So I overheard a bit of the last lecture, you're talking about classification. Imagine a version of classification where you're just trying to predict the next word in a sentence. So I give you a part of a sentence, there are a set of possible options for the next word in a sentence, and you build a machine learning model to predict what that next word is. So you can do this, of course, you've seen how to do this with, say, logistic regression models at small scale. But now imagine this at billions and billions of parameters for extremely large corpuses of data. And under the hood, the key technology that makes all these things work are variations of this simple idea of of word prediction or sentence completion of various kinds. So, the same thing you just learned, but at extremely large scale. And so what it tries to do, again, is it's given text. Some of the text is removed or hidden. And the idea is it's meant, or it needs to find ways, or is trained, if you like, or fit so that it is able to predict the text that it doesn't see. It's rewarded when it gets the right answer. It gets a penalty when it gets the wrong answer. It's trained using stochastic gradient descent that you might have heard today. And this is scaled up significantly, and this is the way that many of the large language models, the vast majority of large language models are trained and deployed. So from here, we get, I think, lots of great applications. One of them, for instance, is collaborative writing. So here's a paper from recently, about a year ago, where they used GPT-3 at the time to help a writer who is composing text, And as you're writing text, you want to get suggestions for sort of ideas of how the text might flow. And so you can use a GPT kind of model. They showed how to use a GPT kind of model for this kind of collaborative writing. As you're writing, it gives suggestions of sort of where things might go. And you can use this to get sort of interesting collaborative writing applications of these kinds of language models. You can also use language models for things like search. So, asking a question like, when did Kendrick Lamar's first album come out? You could have standard search kinds of results for this, but then language models often are increasingly getting good at being able to synthesize answers for these kinds of questions, and additionally give context. So give sort of free-form text that is synthesized tied to an answer to a question. So many of you might have seen this if you played with things like GPT. And so this is meaningful for applications that are traditionally search kinds of applications. So think of Google as a main driver of search applications, and now replacing something that you might ask Google for, where Google will give you a list of results. Now you put this into a language model. It gives you text that's already structured, potentially even images, but this is synthesized for your query. So this is very exciting as a way to try to answer search queries sort of without the current approach that requires work from the user, because they have to look through a bunch of search results to actually get an answer to a search query. So this has been, I think, one of the most potentially disruptive applications, particularly for the large players. I think this is one of the reasons where places like Google are very interested, excited, maybe worried about some of the large language models, because it directly impacts some of the work that they're doing with search. Another application of the large language models is coding. So many of you, I'm sure, are thinking about programming if you're thinking of building machine learning models. And so increasingly, transformer models, large language models have been used to help with code. I think one of the first successful applications of this was GitHub's Copilot, which was I think eventually, well, now GitHub is owned by Microsoft, but also there's an OpenAI Codex, which has a similar kind of tool. And so in these kinds of settings, you start code, you might do a text description of what you'd like the code to do. You feed it into the language model, it gives you some potential code that solves the problem. I think importantly here, it's still important that you know a bit about software so that you can check what the code is doing and sort of fix errors, because I think currently these things are not perfect in trying to solve these kinds of problems. But I think it's a very interesting potential application of these models is the ability to, for instance, build applications. And sometimes people have shown sophisticated applications where you don't have to write any code. You essentially ask in standard text a model to create code. The model creates code that solves certain problems, and then you can deploy this code as actual deployment of software to solve the problem. Again, I think these are getting more and more impressive. I don't think they're fully ready. So I think they sometimes make errors, but I think they're quite interesting as a coding assistant, a coding helper. So if you're building code, have something on the side that sort of helps you think through potential code that you might write, helps you think through things that you might want to fix. If you're stuck somewhere, something might help you with synthesizing new code. So again, you give either initial code, you give it a potential maybe description. It can sometimes do a very good job. So Copilot, as an example, doing a good job synthesizing code to actually solve this text query sentiment classification problem. Again, you could imagine doing this without writing any code. Okay, so let me summarize some of the applications that we've talked about. I think I came up so far. So what are things now in maybe mid-2023 that language models, large language models, I think are quite good at? And I think, if you're working on applications related to this, I think maybe ready to go. Creative and collaborative writing, we've talked a little bit about this, writing ideas. I think these models are good at these kinds of applications. I think meaningfully, these kinds of applications, there's often no right answer for what's the right synthesis should be. The creativity part of it actually, which sometimes is a failure of these models, ends up being a benefit, because here the creativity allows the models to so when they synthesize different things, you can think of these things as creative as opposed to failures of the model. I think they're interesting applications to, for instance, templated writing. So writing where mostly the writing structure is fixed, the content is mostly straightforward. So some simple code, I think, has this format. Lots of formal letters are very direct, so almost copy paste. I think these kinds of applications language models are good for. We've already shown that they can be good at some kinds of question answering kinds of applications. I think they're quite good at some kind of brainstorming. So maybe not directly helping you write, but giving you ideas. I think some of my students have some very interesting applications of language models for critiquing writing. So for instance, we've shown, and others have as well, actually, that you can take a language model, say you're submitting an academic paper to a conference, you ask a language model to write a review of the paper, and it actually does quite a good job and can sometimes help you find holes in your thinking that you hadn't considered, and thinking of ways to improve the development of these kinds of models. So again, can be quite good for brainstorming, critiquing writing, critiquing code sometimes. I think some of the planning applications are quite appealing. So things like travel itineraries, again, cases where there's a human somewhere around that can check what's going on. A human can recover if there's a mistake. I think some of these applications language models have shown to be quite good at. The other question you might ask, and I think the other side of this is, if I have important applications, and importantly, applications without human oversight, if you ask me, should you use the current language models for these kinds of applications? So high stakes decision-making kinds of applications, for instance. When I say this, I'm thinking of colleagues that have asked, for instance, should I use this for medical diagnosis applications? Should I use this for legal applications that may be tied to applications in law? And some of the reason that people ask these questions is that I think they're quite creative evaluations of language models, where people have shown, for instance, that you can take these models, you can ask it questions from, say, the most recent medical exams, and actually the language models will often correctly answer all of the questions from the exam. So this is fascinating because, again, this is something that we thought you needed to be an expert, gone through medical school for many years for. Language models often will sort of successfully pass lots of the exams. So this has been shown, for instance, by OpenAI, Google. Stanford has some papers where they show different kind of language models that can pass language exams. And it's currently not completely clear exactly why these models are good at this kind of application, but people have shown that they can do this well. Yet, and I think because of this, a very reasonable question is, should I take a language model, use it for a high stakes application without human oversight? And given how long I've taken to answer the question, I think you might guess my answer. I think, well, the answer is no. I think this is not a good idea right now in sort of 2023. Some of the reasons that this is not a good idea is that I think while the language models are very impressive and they've shown lots of amazing applications, they still have holes and they still make mistakes. And without human oversight, the mistakes, there are few ways to think about it. One way to think about it is that these mistakes, there's no chain of responsibility. So it's unclear who's responsible for a mistake if a language model makes a decision that ends up affecting a person. So there needs to be someone who's responsible in the loop. Another view is, again, if you're able to check if there's an expert that knows a bit about the area, then I think the combination of expert and language model can be very powerful. But by themselves, I think, again, there are lots of concerns about deployment at scale. So in particular, we've done some work recently. This is a paper we put on archive, I want to say 3 months ago, and it's something that I think hopefully will be through NeurIPS within the next few weeks, and so we can announce. But this is work where we tried to evaluate trustworthiness broadly in the most recent GPT models, so OpenAI language models. And we looked at a variety of different ways that one might try to use the models and potential concerns and how they break. So some of the things that we looked at are variations on security questions. So the first, for instance, if you think of out of distribution. So the idea in out of distribution is that I give a language model some data, then I ask it of the same question maybe, but with some small change in maybe the style of the question. So importantly, many language models are trained on English and especially American English, and especially the generic newscaster style American English. And if you change any of that, sometimes language models behave in unexpected ways. So for instance, here for stylistic reasons, we played with, for instance, Shakespeare style of speaking. But if you do this with, for instance, broken English or any other kind of change in the English style, European English, for instance, which is different from the American style, sometimes language models change behavior in ways that a human who is looking at the models would not expect. So unexpected failures from these kinds of language models. So you can show that the language models sometimes have this vulnerability. We also looked at adversarial robustness. So here you intentionally change words. So this is not a generic style thing, but you intentionally change a word in such a way that the language model, we know, because we've done work on adversarial perturbation of models, that sometimes small changes in text can change the model. The difference from the out of distribution style is here we're only changing, say, single words or small sets of words, as opposed to entire phrases in a different style. And here we showed, for instance, if you change in this sentence here from experienced to skilled, for a human, experienced and skilled mean the same thing. But if you ask a sentiment kind of question for these application, you get a very different response in the model. You're going to also do this within demonstration. So a lot of the, I think, exciting potential directions of these models are tied to having the ability to query with a huge amount of text and to have full long conversations and have it remember old parts of conversations. And we show that, again, there are ways to use this ability to allow for some adversarial vulnerability in the models. We also evaluated, yes.
Hi, Dr. I'm sorry to interrupt you. You have about 5 minutes to the end of your station.
I should be done about that time. Thank you. So we also looked at privacy attacks. So can I, for instance, if someone had put their email in the models, can someone else take a look at that model? If it's part of training, can someone else take a look at that model later and pull out this information from the model? It turns out you can, and people have shown this. We showed this, for instance, for emails that came from this old case of this Enron data set that people use to train models. We've shown that sometimes these models can be biased by sensitive attributes. So we're showing an example here where you're asking two questions of the model. In one case, you use a stereotypically male name, Bob. In another case, you use stereotypically female name tied to a computer science question, and you get a different answer from the model. Again, this is worrying for various applications of models. We checked the extent to which they can follow stereotypes. Sometimes we find that models can do this. We ask ethical questions because, again, there are examples of people doing this with models. We find lots of cases where the models can still have issues in these kinds of settings. So, all this to say, while the models are exciting, I think there's still scope for improving them, and there's still holes in what the models can do. So if you're interested in research and applied directions, there's a lot of interest in reducing errors that the models can have. Sometimes they're called hallucinations, where the models will make up results that don't come from any actual real database. There are issues with citation and attribution of sources. So can I tell where a particular response comes from? There's a lot of interest in multimodal generative models. So many of the big players are building beyond text. Can I do the same kind of things with image, text, audio, lots of sources at the same time? And while they're modeled separately in these areas, combining these together, I think, is still new and quite interesting. And then finally, I think there's a ton of interest in language models that can use tools. So this is some programming API that solves some certain problem. Can I, for instance, if I want to book a flight, can I tell the language model book a flight? It will figure out that it needs to call a flight booking engine, book the flight for me, book hotels, things like that. And there's some early evidence that in some applications, language models can sort of call APIs and solve some more complicated tasks. And so this is quite exciting. A bit on the image application. So for instance, this is image synthesis from text. So many of you might have seen this before, where I give a text prompt, I get an image synthesis. I can do quite sophisticated text prompts. I can ask it to change style. Again, often you have language models. This is from DALL-E 2, but lots of models now that can solve variations of this kind of problem. And I think this direction is potentially interesting for creative applications of various kinds. Okay, so I think language models, they're finding increasingly useful applications in industry and academia. We've covered a lot of them. I think there's a lot of excitement. I think right now, where they're best are things that are tied to scaling, writing, brainstorming, things like that. Scaling, writing, meaning you want to write a lot of things very quickly, and things like brainstorming, where creativity actually helps you. I think there's still issues with trustworthiness. I've shown some examples of harms and applications where these models can break. I didn't talk about this, but there are also potential societal concerns that are not fully worked out in these models. How do you pay for where the data comes from? Or if people have to label data, what's sort of the right compensation model? What are issues with potential job loss if models are deployed for applications where humans used to be the one doing the work? I think there are open societal questions there. And I think, a lot of the work that remains and a lot of work that my lab is excited about is trying to close some of these issues that I think will help potential applications to more high stakes applications. Thank you very much. I have shorter time than I had planned, but maybe a few minutes for a couple of questions.
Wow. Thank you so much, Dr. Sanmi. Okay, before we let you go, we have a couple of questions here. So I'm really excited about what you shared. I mean, giving us the different applications to research and industry. And particularly, I was really happy about you mentioning HITL, that's human in the loop, and either human on the loop consideration, especially because LLM gives inaccuracies. So the first question I'm going to ask is, so how do you cite an LLM in a research paper? Okay, maybe you got your content from ChatGPT. So how do you cite, LLM in output in your research? I don't know if you want to take the questions together, or should I just say one after the other?
Let me try it together for time.
Okay, so the second question is, how do LLM compare to traditional rule-based system in terms of performance and scalability?
Okay, so on the citation one, I think it's unclear. I think it's developing quickly. Many of the large journals, people have been explicitly just adding the LLMs as an author. So they add ChatGPT as an additional author. For some of the areas like like machine learning conferences, I think earlier ICML asked that people not do this or not use this. I don't think anyone knows exactly where things will evolve to. Probably right now, the right way to do this is to ask the place you're submitting to and ask what their policy is, just like everything else with these kinds of, with sort of unknown questions or modern technology. I think the least issues, the route with the least issues is just ask the journal, and I think you'll have different answers in different places. So that's probably the right way to go. In terms of scalability, LLMs are not that scalable. So I didn't talk about infrastructure at all, but getting LLMs to work generally requires a huge amount of computation. In fact, I think this is the reason why there are not that many players in this space of building really big LLMs. It really does take millions and millions of dollars for the computation, engineering, all that to get these models to work. I think because of the excitement in terms of their usage, people are willing to put in the resources. But I think there's still a gap in terms of scalability compared to other ways that people have been trying to solve, say, search problems or retrieval problems. They do meaningfully different things, though. So I think excitement is because it's not a one-to-one comparison in terms of performance. If I narrow to a particular rule-based, say, retrieval application, if I know that that's all I care about, I would still say you're better off by far using a traditional rule-based model, purely from an applied point of view, both performance and scalability. But I think the excitement in large language models is the variability, the flexibility to go beyond a particular application to sort of generic use case, even use cases that I haven't explained here, that you haven't thought about, that someone else will come up with in the future. So that flexibility is what is exciting, but it does come with a performance and scalability cost that can be quite high.
All right, thank you so much for answering that question very clearly. So I'm having two other questions. So how can hallucination be minimized in LLM? And the second one is, human can have bias in decision making. Is it possible to eliminate bias from AI and ML models? So I think that'll be our last two questions.
Yeah, both very interesting, important questions. So hallucinations, I think it's a very active research question because we don't know the answer yet for how to do it well at scale. Some of the methods people are trying, there's a bunch of work in trying to get the model to critique itself. So I mentioned briefly that language models are good at critiquing text. It turns out they're also good at critiquing themselves. So you ask them to sort of, can you check this response you gave me? Is this response correct? Can you cite your sources? Things like that. And there are cases where you can show language models, if you do this iterative loop of asking it to check itself, sometimes will do better in like reducing errors that it makes. The applications or approaches that try to use reasoning. So this is classic, not so classic, but sort of reasoning from programming language type views or other kinds of logic, other areas of computing that have very formal ways of thinking about attribution and decision making, and asking whether you can build models that use some of these additional tools as part of how they answer questions. And so maybe in this way, with a grounded logic, can I make sure that the model is not hallucinating? I think, again, research is still out on this. It's not completely clear, sort of the perfect ways to get these things to work. So these are still open. So other things people are trying, but again, I think this is very active research, so I don't have a clean answer for this. I think whoever solves this first, I think will have a big advantage in either research or on the business market. I think it's one of the biggest holes in this space. In terms of bias, I think your question is quite important because, again, I've talked a lot about the bias that models can have. I think there's a very reasonable response that the bias that the models can have often looks like the bias humans can have. I think one of the nice things about models is that because they're algorithms, we can query and interrogate and evaluate them in a much more structured way than we can often do with people. So, for instance, there's lots of examples and evidence that, even people that are supposed to be extremely thoughtful and logical, say doctors, judges, often have bias in their decision-making if you actually look at lots of decisions and sort of ask them questions the right way. And it's hard for people to acknowledge these issues. Language models, machine learning models in general, because of the nature of them being algorithmic systems, you can query these and sort of ask explicit questions about where biases are and where they're coming from. I actually think, taking a step back, this is in some ways an advantage of language models, and that they allow us to rethink some of the holes in decision-making in general, where bias comes from, in ways that would have been much harder to do with people. It's also true that humans play a huge role. I think a big through line in a lot of my conversation today is that humans decide how to build a model. Humans decide whether something the model spits out is good or bad. And if a human, humans will have bias. All of us have biases of different kinds. All those biases ends up in the model itself. I think some of I think the fact that these are algorithms gives the potential for querying those biases in ways that are hard compared to people. So, I take heart in the fact that because it's an algorithm, because it's going to be deployed at scale, there is a system around it where we can ask where the biases are. People can figure out, if those biases match what they would like a model to have, say in society, in large groups, things like that. If they don't, this is something that's fixable in a machine, not fixable in humans. And so if you like, we can tune the biases in directions that we like. And hopefully, this is maybe going back to humans having agency. Hopefully what ends up happening is that we make decisions that are better as a collective than we would have made, say, as individual decision makers. I think this part is hope. I think it's a very fair point that in the end, it's very tied to human decision makers, but it does allow for this kind of community decision making, this kind of evaluation of what the models are doing in ways that you can't do with people nearly as easily. So I think that that's a hopeful part of these models.
Wow. Thank you so much for taking your time to really be extensive in answering those questions. Thank you so much, Dr. Sanmi. Please, participants, can we appreciate Dr. Sanmi in the chat? I mean, it's been very, very down to earth, detailed about the questions and the session. I know we don't actually have so much of time. Dr. Sanmi would have shared more with us, but we apologize. So we're looking forward to having you next year or some other time during our community